All right. In 3.3, we're talking about two basic rules of probability, the addition rule and the multiplication rule. We'll start with the multiplication rule first. Bring a few things up here. That's good. All right. So what is the multiplication rule? So the multiplication rule applies when you want to calculate the probability of the intersection of two events. And so the way that we can talk about the intersection of two events, here I've got a Venn diagram down below. So you can see here, this is event A, here is event C, and the intersection is where those two events intersect, where they overlap. So the way that we talk about this intersection is we talk about it as event A and event C occurring. So this is the probability of A and C, which is the same as saying the probability of A intersect C. So this symbol, which is an upside down U, that means intersect. All right, so when we go to calculate the probability of the intersection, the multiplication rule takes two forms. And I think you'll see that these two forms look familiar because these two forms were responsible for testing independence, right? So in the previous section, we used this formula. And when this probability on the left equaled the probability on the right, then we would say that those two events were independent. So without knowing it, you're actually applying the multiplication rule when you were testing for independence. If it fails this test, then they're not independent. The two events are dependent. And since they're dependent, then to calculate the probability of the intersection, you had to use a different rule, okay, or a different equation. That's this one. Yeah, so these are the two forms of the multiplication rule. And in order to know which of the two forms you need to use, either this one or this one, you have to test and see whether the two events are independent or dependent. And that tells you whether to use this equation or whether to use that equation. This table just kind of takes you back to the previous section where we did a test of independence. You look at these two Venn diagrams, you can't really tell right off the bat, which two events, A and C, are dependent or independent just by looking at them, and maybe just not by, seeing about how they're defined. But we applied this test of independence here. And in the case where the quantity on the left does not equal the quantity on the right, then that tells us that they're not independent, they are dependent. Whereas if we carry through with this same test of independence and the two quantities are equal to each other, the expression on the left is equal to the expression on the right, then that tells us that those two events are independent of each other. Okay. So that's just an introduction to those two equations. Let me know if you have any questions.